Hello, friends. Welcome back to Nelly Max Concept. It's been a while, actually. If you are seeing me for the first time, my name is Nelson, and this is Nelly Max Concept. I would like you to subscribe to this beautiful channel, like our content, drop comment on our videos, and also share our content. Thank you so much. Today, we have a very interesting topic, permutations and combinations. But our focus is going to be on combinations. Now let's look at the outline of our lesson today. We will define combinations. Then we solve problems on combinations. Let me give a disclaimer here. If you are preparing for JAMB, you are going to write mathematics in your JAMB. This lesson is very, very important for you. You need this lesson. Of course, everyone needs this lesson, but most importantly, I encourage everyone that's going to write mathematics in JAMB to watch this video. All right, let's look at the definition of combination. Combination is a way of selecting items from a collection such that the order of selection does not matter. Emphasis on the order of selection. The order of the arrangement does not matter. Unlike permutation that we learned in our previous lesson, in which the order of arrangement or selection matters. So in permutation, the order of arrangement matters, but in combination, the order of arrangement does not matter. Now, let's take an instance. Cephas, Abuchi, Ferhat, John, and Nuruddin are five mathematicians. Now, there's a question here. In how many ways can three of them be chosen or selected to represent Nigeria in a mathematics competition? All right, so interesting. Now, I want us to solve this question manually. Let's solve it the way a layman would solve it. We have five mathematicians in the same department, Sifas, Abuchi, Ferhat, John, and Nuruddin. So how can three of them be selected to represent their country in a mathematics competition? Now, you see that Sifas, Abuchi, and Ferhat, this is a possible combination, okay? This is a possible combination of three, all right? Then Sifas, Ferhat, and Nuruddin is another possible combination. Abuchi, Ferhat, and John, another possible combination. Abuchi, John, and Nuruddin, another possible combination. Abuchi, Nuruddin, and Sifas is also another possible combination of three mathematicians. We can also have Ferhat, John, and Nuruddin. We can as well have Nuruddin, Abuchi, and Ferhat. We can as well have Ferhat, Sifas, and John. And we can as well have John, Sifas, and Abuchi. Now, these are the possible combinations of three mathematicians. There are 10, okay? We have 10 possible combinations. Okay, now there's one thing I want us to note here. Now, you see that in this first combination, Cephas, Abuchi, and Ferhat, the order of the selection does not matter, okay? It does not matter if Cephas is the first person, or Abuchi is the first person, or Ferhat is the first. All right, the order of arrangement does not matter. Abuchi can be first, Cephas second, then Ferhat third, okay? Or Ferhat first, Cephas second, Abuchi third. So they can be arranged in any way. So the order of the arrangement does not matter. Same thing is happening here in the second combination on and on to the 10th combination. So the order of the arrangement or selection does not matter. It is simply a team of three. Okay? A team of three. Okay, three mathematicians. All right. So this is the striking difference between permutation and combination. Okay, if this is to be permutation, we will surely have more than 10 possible arrangement. All right. If we are given a question on this topic, uh, we will not always solve it this way. Okay. As I said, this is just a manual way of solving this kind of problem. So we will not always solve questions on combination this way because if the numbers are large, okay, we'll find it so difficult to list the possible combinations or arrangement. It will be quite hectic, it will not be easy at all. So there is a formula that we can always use to solve problems on combination. I have it here. The combination of R element given N element is given as what? N combination R is equal to N factorial upon N minus R all in bracket factorial times R factorial. With this formula, we can solve problems on combinations easily without any stress. Okay, the N is the total number of items, okay, or the sample space, while the R is just a sample, is what we are choosing from the whole. Okay, like in this case, our R is 3, then our N is what? 5. Now let us solve this same question the right way, okay, or the normal way. Okay, we have it here. In how many ways can a committee of 3 mathematicians be selected from 5 mathematicians? Very, very interesting. Now let's look at the solution. As we already know, the formula is what? N combination R is equals to N factorial all over N minus R all in bracket factorial, then times R factorial. Our 5 is what? Our N is what? 5. Then our R is what? 3. And the formula is given this way. Don't forget, in our lesson on permutation, we defined what a factorial is. All right, 5 factorial means 5 times 4 times 3 times 2 times 1. Okay, 10 factorial, for instance, is what? 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, just like that. Multiply the number down until you get to 1. All right, so we are going to express 5 factorial as what? 5 times what? 4 times 3 factorial. All right, 5 minus 3 is what? 2. Then we retain our factorial, right? Then 3 factorial remains here. As you can see, 3 factorial and 3 factorial can actually cancel out. Okay? 3 factorial over 3 factorial is 1. Then 2 factorial is what? 2 times 1, which is 2. So 2 divides 4 will give us 2. Then 5 times 2. This dot is times, okay? So 5 times 2 will give us 10. All right, so that is what is happening here. Very, very simple. So with this, we don't have to list the possible combinations of 3 mathematicians. It will actually, it's time consuming, and in exam you don't really need to waste time. You need to like apply the formula and get your answer as quick as possible. Guys, it's very, very simple. Just know when your question is permutation or combination. If you look at the question and you see or you know that the order of arrangement does not matter, then it is what? Combination. Then you apply your combination formula and your answer will be right there. Okay? But if in a given question you see or you can see that the order of arrangement matters, then it is a permutation question. Then you apply permutation formula. I have a video on permutation. So you can check my channel and watch that video. Let's look at the second example for today. Example 2. In how many ways can a team of 3 girls be selected from 7 girls? These are the options. Don't forget, these are jam questions. Let's look at the solution. We recall our formula, right? Our n is what? 7. And our r is what? Our r is what? 3. So we have 7 factorial all over 7 minus 3, all in bracket factorial times 3 factorial. And that gives us 7 factorial over 4 factorial times 3 factorial. And that is option D. So option D is the correct option. It's very, very simple. So you don't need to overtake the options, okay? Stop where the options stop. Is that clear? All right, thank you so much. Now let's look at the third example for today. Example 3. In how many ways can a student select 2 subjects from 5 subjects? Okay, as you can see, this question is purely a combination question. Do you understand? A student has 5 subjects and he wants to select 2 subjects. Let's assume physics and chemistry. Okay, so if he chooses physics and chemistry, the order does not matter. Okay, it can either be physics and chemistry or chemistry and physics. So the order of the arrangement or the selection does not actually matter. So this is combination. So we can apply combination formula and get our answer. It's so trivial. We have, applied this formula like 2 times or 3 times here. So it's very, very trivial. All right. So the correct option here is what? 5 factorial over 3 factorial times 2 factorial, which is what? Option what? A. So option A is the correct option for this question. Just know when it is combination, record the formula, then substitute for n, also substitute for r, and you are good to go. Very, very simple. Okay, let's look at the next example. I actually have a lot of questions to solve with you today. Now let's look at this. Evaluate n plus 1 combination n minus 2 if n is equal to 15. If n is equal to 15, how do we evaluate this? And we have the options. Okay, let's look at the solution. It is very, very simple. You can even pause the video and solve it yourself. I used to do that also. All right, so you can pause the video, solve it, and get an answer. Then you play the video to see if the answer you got is same as what is gotten here. All right, we have n plus 1 combination n minus 2, and we are given that our n is what? 15. Okay, so let us solve. Okay, now if n is 15, that means we are going to have what? 15 plus 1. Okay, combination 15 minus 2. Is that clear? And that will give us 16 combination 13. All right, 16 combination 13. Then we apply our formula as usual. All right, our n is what? 16. Okay, then our r is what? 13. All right, so 16 minus 13 gives us what? 3. Okay, then we retain our 13 factorial. All right, we have 16 factorial over 13 factorial, and we already know what a factorial is. Okay, 16 factorial is same as 16 times 15 times 14 times 13 factorial. We stop at 13 factorial so that the 13 factorial down can cancel the 13 factorial up. Okay, if we have over 10 factorial and we have 16 factorial up, what we'll do is we express 16 factorial as 16 times 15 times 14 times 13 times 12 times 11 times 10 factorial, so that 10 factorial up and 10 factorial down can actually, cancel out. Okay, to make it very, very easy for us. Don't forget, 10 factorial is same as 10 times 9 factorial. Okay, 10 factorial can as well be expressed as 10 times 9 times 8 times 7 times 6 times 5 factorial. Okay, you can just be going down. Then anywhere you choose to stop, put factorial there. It doesn't change anything. All right, so that is what is happening here. So at this point, 13 factorial and 13 factorial can actually cancel out, so that we'll have 16 times 15 times 14, and 3 factorial is what? 3 times 2 times 1. Is that clear? So 3 here can divide 15 to give us 5. Then 2 here, 2 at the bottom, can divide 16 to give us 8. So what we have left is 8 times 5 times 14, and that returns 560. So option D is the correct option. All right, let's look at the fifth example. Okay, example 5. In how many ways can a committee of 2 women and 3 men be chosen from 6 men and 5 women? All right, guys, let's look at the solution. As you can see, we have 5 women to choose 2 women from. We also have 6 men to choose 3 men from, so that these 5 persons will form a committee, and that committee is made up of 2 women, and 3 men. That is what this question is asking us to do. So we are going to recall our combination formula. We apply it accordingly, and we have our answer. 5 combination 2 can be expressed as 5 factorial upon 5 minus 2 all in bracket factorial, then times 2 factorial. Same thing happens around 6 combination 3, and that gives us this. 5 factorial can be expressed as what? 5 times 4 times 3 factorial. So that this 3 factorial up can cancel the 3 factorial down. Is that clear? Then 6 factorial can as well be what? Expressed as what? 6 times 5 times 4 times 3 factorial. Alright? So 3 factorial up can go with this 3 factorial down. Also, this 3 factorial here at this side can also cancel this 3 factorial down. Alright, so what we have left is what? 5 times 2. Okay, how do we get this 2? This 2 is gotten, this 4 up can be reduced by this 2, this denominator 2. Okay, so it can reduce our 4 to 2. So we have 5 times 2. Alright, then times 2 times 5 times 2. Alright, so um, this is how we got all this. 3 can divide 6 to give us 2. Is that clear? Then 2 can divide 4 to give us 2. So you multiply the resultant, then we have 200 as our answer. So the correct option is what? Option D. This is very, very simple. In combination and permutation also, you don't find it difficult to solve the problem. Sometimes the difficulty comes in understanding the question, okay, in understanding what to do. It could be trying to figure out whether it is combination or permutation, or it could be how can I apply the formula. Like this particular example now, you see that we use multiplication, okay, and that is how it is supposed to be, because it is independent. The selection process is independent. We have 5 women and we have 6 men, so you are selecting two women, and you're also selecting 3 men from men to form a committee, okay, of 5 persons. So you are doing this independently, so you can actually use multiplication, okay? So you have to think more and write less. That is what happens in permutations and combinations. Thank you so much. Let's look at the next question. We have example 6 before us. In how many ways can a delegation of three be chosen from 5 men and 3 women? Okay, if at least one man and one woman must be included. All right, a condition is given to us here. Okay, we have a condition. This is what we call conditional combination or combinations with conditions. Okay, so I'm going to do a video on that. Okay, we'll solve a number of questions that have conditions. All right, so that we will gain mastery on this topic. Okay, all right, guys, let's look at the solution. You see, it's either we choose one man from the 5 men and 2 women from the 3 women, or we choose 2 men from the 5 men and 1 woman from the 3 women to form this delegation. Is that clear? So you see that whichever way there is at least one man and 1 woman in our choice. Okay, so these are the possible choices we can make. Okay, so and don't forget that or is what plus. Okay, in combinatorics. All right, so we have it this way. You apply your combination formula. Don't forget that or is what plus. All right, so always, as I said earlier, this is very, very simple, but you have to think more and write less. You have to understand the question very well before you start solving. Okay, so let's go on. We have 5 factorial all over 5 minus 1 in bracket factorial, then times 1 factorial, then times 3 factorial upon 3 minus 2 factorial times 2 factorial. All right, so let's simplify further. So you see, 5 minus 1 gives us what? 4 factorial. Then 3 minus 2 returns 1 factorial. Also here, 5 minus 2 returns what? 3 factorial. Then here also 3 minus 1 factorial returns 2 factorial. All right, let's solve further. Let's keep solving. So you see that at this point, what we have left is what? 5 times 4 factorial upon 4 factorial times 3 times 2 factorial upon 2 factorial plus 5 times 4 times 3 factorial upon 3 factorial times 2 factorial times 3 times 2 factorial all over 2 factorial. As you can see, we have um, factorials that can actually cancel out. For instance, 4 factorial can go with 4 factorial, 2 factorial can as well go with 2 factorial, so that we'll have 5 times 3 left. Okay? Then this 3 factorial up can as well cancel this 3 factorial down. Same thing happens, 2 factorial over 2 factorial can also go, so that we'll have what? And don't forget that 2 factorial is 2. So it will reduce this 4 to what? 2. Alright? So we can have 5 times 2 times 3. Okay? And that gives us 15 plus 30, which is what? 45. Very, very simple. The solving is not difficult, okay? The solution is not always difficult, okay? So I think the emphasis should be on the question, that is understanding the question. You have to do well to understand the question, okay? And from what we have done so far, I know you have gotten enough clues that will help you in understanding questions on combination. When you understand the question, you sure know what to do. Alright guys, let's look at the last example for today. For what value of n is n plus 1 combination 3 equal to 4 into n combination 3. Look at the options. Guys, this is not hard at all, okay? Just apply what you know and you get the answer. So let's look at the solution. It is not going to be difficult at all. All right. So this is the question. So we have to apply the formula the normal way we have always applied it. Okay. So we have n plus 1 up here. So we have n plus 1 factorial. Don't forget that n combination r factorial is what? N factorial all over. Okay. So whatever your n is, add factorial to it. Okay. So here we have n plus 1. So we have to write n plus 1 factorial. Then all over this n plus 1, okay, minus 3. Okay, then they all should be in bracket, put your factorial times 3 factorial. This is the formula, okay? Nothing changed, all right? So same thing, happens at the right hand side. Okay, guys, let me call your attention to something again. We have also applied it several times in this example. If we have 5 factorial can be expressed as what? 5 times 4 factorial. Is that clear? So same thing can as well happen here. Okay, n plus 1 factorial is also same as what? N plus 1 times n factorial. Okay, we have n factorial at the right hand side. So we want to see if we can as well have n factorial at the left hand side so that they can both cancel. Our aim is to eliminate factorials in this expression. This is an equation. So if we can eliminate all the factorials, it will be very easy for us to solve. Is that clear, guys? So n factorial, this n factorial at the right hand side is a factor of n plus 1 factorial. So that means we can express n plus 1 factorial as what? N plus 1 into n factorial. So that this n factorial here can cancel the n factorial at the left hand side. Is that clear, guys? Okay, so let us proceed. Okay, as you can see, this n factorial can actually go with this n factorial, okay? Then we have 3 factorial as the denominator, okay, of the left-hand side equation, of our equation. Then we have 3 factorial also at the right-hand side, so they can as well cancel out. As you can see, we are reducing the factorials in the expression. So what we have left? N plus 1, okay, over n minus 2 factorial, then equal to 4 into 1 over n minus 3 factorial. Now, we are also going to eliminate these factorials, okay, in the left-hand side and in the right-hand side. Okay, now let's look at it. N minus 2 factorial is bigger than n minus 3 factorial. So what that means is that n minus 3 factorial is a factor of n minus 2 factorial. Is that clear? So that means for us to eliminate the factorials in both sides, we have to express n minus 2 factorial as n minus 2 times n minus 3 factorial. Okay, it is still the same. Nothing has changed. Okay, just as the way you would express 5 factorial as 5 times 4 factorial. Nothing changes. All right, let us do that and see the result. Okay, so our n minus 2 factorial is same as n minus 2 factorial all into n minus 3 or factorial. So at this point, our n minus 3 factorial here at the left hand side can actually go away or cancel out n minus 3 at the right hand side. So if that is done, we have n plus 1 upon n minus 2 left in our left hand side, okay, of the equation. Then at the right hand side of the equation, we have 4 over 1. So when we cross multiply, we have n plus 1 equal to 4n minus 8, 4n minus 8, and we collect like terms, and we have minus 3n equal to what? Minus n. And that gives us 3 as the value of n as required by the question. Very, very simple, okay? You just have to think more and write less. Think more, you write less. All right, it's an interesting question. I believe you have learned a lot, okay? How to take care of your factorials, okay? You are going to see similar questions as you journey further in mathematics. So, always, apply this knowledge. Always apply this trick, okay, to take care of factorials. Guys, I believe with this, you have learned how to take care of your factorials, okay? It's very, very simple. Just know that n factorial is same as n times n minus 1 factorial. Or you can simplify further to have n factorial is equal to what? N times n minus 1 times n minus 2 factorial. And, it's just so simple. Thank you so much, guys, for your time. I really appreciate. All right, I have a take home for you. I call it check yourself. Okay, I have just two questions for you to solve. Okay, solve these two questions. Okay, if you really understood the lesson, these two questions will not be difficult for you at all. Okay, solve these questions, drop your answers in the comment section. Thank you so, so much. All right, we shall meet again in my next lesson. Kindly subscribe to this channel and like this video. Thank you so much.